I want to give you a really short CV. This is not because I think that you'll be particularly interested in my CV, but it has some bearing on what I want to say later on. So let me just take you very quickly through where I've come from. I started off as a mathematician, and as an undergraduate, I would have said that I was interested in pure mathematics. I felt that pure mathematics was like the queen of the sciences. It was the highest state of knowledge, if you like. So I started off with that kind of mindset. And gradually, as I began to study mathematics, I became more and more interested in applied mathematics, so using mathematical models to describe the real world. And so I went on to do a PhD in applied mathematics. In fact, it was in mathematical biology, so I was interested in mathematical modeling of biological systems. I felt at the end of that the mathematics that I was doing was not really speaking to the biologists in the way that I wanted it to. So at that point, I did a postdoc, and amazingly, I was given a job as an experimentalist in a lab doing some cell biology experiments. I wouldn't say that I was converted to becoming a biologist, but I spent a long time working on experiments and working with biologists in that context. I actually did a second postdoc where I was trying to bring those two strands of thought more closely together. And then eventually I got an academic position, and my current position is a joint position between the Faculty of Medicine and the School of Mathematics. So I'm attempting to bring these two ways of thinking together. And so I have some experience in both of them. And I wanted to try and share with you some of my thoughts about that experience. So I'd like to start at the beginning, and I'm going to give you some quotes to kind of illustrate where I'm coming from. So this is a famous mathematician, G.H. Hardy. He spent most of his time in Cambridge, but some time here in Oxford. And so he said this, he was a pure mathematician: beauty is the first test. There is no permanent place in the world for ugly mathematics. And I think this is such an interesting quote. I think it's really interesting because it says, well, there is a kind of immortality. There is something eternal. And that thing that is eternal is mathematical. But it's not just mathematical, it's beautiful mathematics in some way. So his belief really was that beauty was the first test. So if you're a pure mathematician, really that's what you're looking for: elegance, harmony, simplicity, if you like, in your theories. And there's no place for ugly mathematics. It might be right in the sense that it's a workable proof, but it's not right in the sense that it's a good piece of mathematics. So that kind of idea really permeates lots of pure mathematical thinking. I was really, really interested in pure mathematics for a long time. This is another picture of Paul Erdős, a very, very famous 20th century mathematician. He had this idea that God has a celestial book. And in this book are written the purest, most elegant proofs. And so his highest compliment to someone was to say, well, this one is from the book, capital T, capital B. He said, you don't have to believe in God, but you should believe in the book. So somehow this is really what we're striving for, this kind of elegance, this kind of beauty in our work. And that kind of thinking really permeates lots of mathematics in my experience. And because lots of physicists come from that kind of mathematical background, it starts to permeate the way in which lots of physicists think as well. So this, of course, is Richard Feynman, a hugely influential physicist. And he said this: you can recognize truth by beauty and simplicity. Inexperienced students make guesses that are very complicated, and it sort of looks like it's all right. But I know that it's not true, because the truth always turns out to be simpler than you thought. So if you're a young physicist coming to physics or coming to mathematics, and you hear the greats like this say, if you think it's complicated, you're getting it wrong, you're an inexperienced student, well, you don't want to think that of yourself, do you? You want to think that you're a sophisticated student. So these kind of statements are enormously influential in mathematics and enormously influential in theoretical physics. And so this kind of permeates the way in which lots of us think about theory in particular. Now, as I began to have more and more exposure to biologists, I realized that they really don't see things like that at all. So this is a quote from Richard Preston. He's actually a journalist. He writes for the New Yorker. And he said, in biology, nothing is clear. Everything is too complicated. Everything is a mess. And just when you think you understand something, you peel off a layer and find deeper complications beneath. Nature is anything but simple. And so the sort of counterpoint to this very pure way of thinking, this mathematically led way of thinking, doesn't really feature so prominently in the biological sciences. In fact, in the biological sciences, things are enormously complicated. They're rich, you would say. There's diversity. There are And there's great beauty in that diversity. And so biologists would generally cherish that kind of complexity, that kind of beauty, that kind of feeling that the world is very, very complicated. And as we peel off one layer, we just get down to more and more depth, more and more complexity. So as I began to work more and more with biologists, I began to feel that this kind of feeling was certainly more present in the biological science community than in the physics community. Now that's not that, of course, is a generality. Not everybody thinks like that, but in general, there seems to be this kind of feelings amongst the biological sciences community. Now, of course, you can bring those two feelings together. This is a quote from the very end of The Origin from Darwin, and he says, "There is grandeur in this way of life. From so simple a beginning, endless forms most beautiful and wonderful have been and are being evolved." So there is a kind of interplay between some simple driving principles and the complexity that we observe in the real world. But it's not such a sharp dichotomy as you would see in the physical sciences. As I began to move more and more into the experimental sciences, I was really, really interested in interdisciplinary research. How can we bring together different communities? How can we bring biological scientists alongside mathematicians, say, to work collaboratively? And I kind of I wanted to really dissect why it's so difficult to do that. And so, of course, at the very top, if you imagine sort of layers of depth going deeper and deeper and deeper, trying to understand why we have these different ways of thinking. Well, obviously, the biological sciences and the physical sciences are generally interested in quite distinct problems. There is an intersection, of course, with biophysics, but often they're very different interests. Because they come from different places, they have different histories, and those different histories mean that they use different languages to describe the real world. And some of that language is overloaded. So the term model, for instance, has numerous different meanings depending on who is saying it. So those, if you like, are relatively superficial differences that could be overcome, but more deeper than that, they come from slightly different perspectives on the real world. In general, biological sciences, in my experience, are more interested with the sort of here and now diversity of the real world rather than some abstracted realm. So they have a kind of different philosophical underpinning. But below that, I would argue, there is this different conception of what is attractive, what is desirable in science. And from the mathematical side of things, we would think about this sort of pristine world of elegance. And on the biological side of things, we would think about complexity and abundance and so forth. So I began to feel that perhaps at that bottom level, that was one of the main difficulties with bringing the communities together. So having said all that, I wanted to share with you 4 thoughts, and these are just my thoughts, really, that I don't hold them very tightly, if you like. They're just openers, if you like, to kick off a discussion. So my first thought is that feelings of beauty and wonder and awe, they're really innate responses to the natural world, and they're primary motivators of our investigation of it. Everybody is seeking something attractive. That the definition of what is attractive might vary from person to person, but that is a primary motivator for us. That's important because what we find beautiful or attractive determines the questions we ask and the answers that we consider plausible. So it's important that it even determines the questions that you would ask. So if you were interested in an answer that was mathematically elegant, you would ask a question that's likely to lead you to that. If you were interested in the abundance and complexity of life, you would ask questions that will lead you to that. So it's very important because it kind of hits to the root of the kinds of questions that we might ask as scientists. The third one is that our perceptions and our perceptions of beauty are conditioned by our biology and thereby our place in the natural world. So the way in which we think is determined by our biology. So the way that we perceive the world is determined by our biology. So what we find attractive in the world is determined by our biology. So for instance, in my opinion, if we're ever to come to a grand unified theory of anything, we have to account for the fact that the ones doing the theorizing have a particular biology and a particular place in the natural world. And then finally, I would argue that science is the process of exploring the world as it is, not as we would like it to be. So beauty can be a great guide for us, and it can spur us on to looking into the natural world. And beauty can help with us in that, but we shouldn't be dogmatic, of course. This is a picture of, does anyone know what this is a picture of, this dog?
Dogmatics.
Dogmatics from Asterix, yeah. So I feel that we have to cultivate a view of the world that allows for all of these diverse perspectives, including diverse opinions of what is beautiful. So I'll finish there. Thank you.